Assalamualaikum and a very good day. In this video, we are going to have a look on the chapter Trigonometry. So basically, these are the things that you need to know for this chapter. Okay. The first thing, know the 6 trigonometric functions of angle in any magnitude. Okay. Basically, this is just sine theta, cos theta, tan theta, and sec theta, cosec theta, cot theta. These are the things, and we know that tan theta is just equals to sine theta over cos theta, and cosec theta is just equals to 1 over sine theta, and then cot theta is just equals to 1 over tan theta, such that it is just equals to cos theta over sine theta. So basically, these are the 6 trigonometric functions. So we are going to have a look at it later. Second, understand the amplitude and periodicity of the relationship between the graph trigonometric function. This one, we've done it in our previous class. So we've done sketching we've done number 2 and number 3. We've done all the sketching. The next one is use the relationship. And this one we will cover later. The next one is solve simple trigonometry equations. Okay, the last one is proof simple trigonometric identities. Okay. So basically, these are the things that you need to know in order for you to answer the question for chapter trigonometry. Okay. So in today's lesson, I will try my best to cover all the important points or important information that you will need to know in order to answer question in this chapter. All the basic properties, basic things that you need to know. Okay, we will start with the first one. There are a few things that you need to know. Okay, we start with the first one, which is the quadrants. Okay. So what is quadrant? Basically, on a Cartesian plane, there will be 4 quadrants. For example, the first one is known as quadrant 1. How to spell is Quadrant. Okay, quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay. Suppose that I have an angle, say maybe 36 degrees. Okay. The way we draw this angle, so 36 degrees lies in quadrant 1. Okay. How about maybe say 280 degrees. Okay, 280 degrees, if you draw 90 degrees, 180 degrees, 270 degrees, 280 degrees. So maybe here. Okay, so 280 degrees. So 280 degrees is in quadrant 3. Quadrant 4. Okay? And also, notice that one round is 360 degrees. Another round, we will have 720 degrees. Another round, we will have 1080 degrees. So for each round, each round equals to 360 degrees. So the main point here is the first quadrant, second quadrant, third quadrant, and fourth quadrant. And it goes anti-clockwise in that direction. Okay. Now let us recognize what is positive angle and what is negative angle. Okay, when we talk about positive angle, it is the angle in anti-clockwise direction. For example, this is a positive angle. Theta is positive. How about negative angle? Negative angle in anti-clockwise direction. For example, this theta here. Okay. Let us just sketch theta equals to maybe 160 degrees. Okay. So this one is 90 degrees, 90 degrees, 90 degrees, 90 degrees. Okay. So you should know that total in one circle is equals to 360 degrees. So when we have 160 degrees, means that we start from here, 0, until here. Okay, so this theta is equals to 160 degrees. Okay, because this is half is 180 degrees total. Okay, so that is theta equals to 160 degrees. How about if this is I go anti-clockwise. If I have another angle, this angle here, okay, I name this angle as lambda. Okay, so lambda is just equals to negative because it goes clockwise direction. It goes down here, top. Okay, so we put negative because of the direction. The value of that angle is just 360 degrees minus 160 degrees, because one total round is 360 degrees. So we should get lambda is just equals to negative 200 degrees. Okay. So say I have we want to draw negative 50 degrees. Okay, so theta equals to negative 50 degrees. So we should start from here, 0, going down a bit, and there. Right? So negative because the direction goes clockwise. So this is your theta equals to negative 50 degrees. Okay? So I hope you understand what does it mean by positive angle and negative angle. Positive angle, it goes clockwise direction. Negative angle goes anti-clockwise. Positive angle goes anti-clockwise direction. Negative angle goes clockwise direction. So means that positive angle it goes like that. Negative angle it goes down. Okay. Now let's have a look at on the relationship of positive and negative angles. Suppose I have an angle theta equals to 30 degrees, and obviously theta is just an acute angle. Okay, acute angle means it's below 90 degrees. So if I just randomly sketch, okay, let me name this as theta equals to 30 degrees. Okay, suppose that I have the corresponding negative angle for theta for 30 degrees. I name this as lambda. So the corresponding negative angle is just this angle here. Okay, so lambda is just equals to obviously negative 360 degrees minus 30 degrees. So lambda is just equals to negative 330 degrees. Okay, so we can say that lambda is just equals to negative 330 degrees. Now take your calculator and find the value of sine 30 degrees. Okay, if you press your calculator, you will get a 0.5. How about sine negative 330 degrees, which is just the corresponding negative angle of 30 degrees? You will also get 0.5. Try to find for cos 30 degrees. You will get 0.866. And and cos negative 330 degrees. Press your calculator, you will also get 0.866. How about tan 30 degrees? You will get 0.577, and tan negative 330 degrees equals to 0.577. And if we observe the pattern here, we can say that sine 30 degrees is just equals to sine negative 330 degrees. Okay, and cos 30 degrees is just equals to cos negative 330 degrees. Tan 30 degrees is just equals to tan negative 330 degrees. That is from what we observe in this example. So if I want to make a conclusion, suppose that I have an angle here. The positive angle, I give it theta. the negative angle, I call it as lambda. We can say that sine theta is just equals to sine lambda. Cos theta is just equals to cos lambda. And tan theta is just equals to tan lambda. Such that relationship between theta and lambda is just lambda is equals to negative 360 degrees minus theta. Okay, obviously lambda is just equals to negative. Why is it negative? Because it goes that direction. Okay, it's just equals to 360 minus theta. Right, now let's have a look at more examples. Okay, suppose that I have sine 200 degrees. So if 200 degrees, it should be 90. So this is 90, 180, 270. But we need 200, so probably your graph will look something like this. Okay, so this is 90, 180, 200 and 200 degrees. So this is 200 degrees. And the corresponding negative angle here negative 160 degrees. So we can say that sine 200 degrees equals to sine negative 160 degrees. Cos 200 degrees is equals to cos negative 160 degrees. Tan 200 degrees is equals to tan negative 160 degrees. And if you press your calculator, for both, you will get negative 0.342, and then cos 200 equals to cos negative 160 degrees equals to negative 0.9397. Okay, and the third one equals to 0.363364. Sorry. So write your answer in at least 3 significant figures. Okay. Next one. Okay, if we have our angle in a form of radian, okay, so pi means that the angle is in a form of radian. So where is pi over 4? This is pi. Okay, from here to here, this is pi. And this is pi over 2. So we know that pi over 4 should be in the first quadrant. So say this is your angle, pi over 4. Okay. The corresponding negative angle is just equals to 1 whole circle is 2 pi minus with pi over 4. So 2 pi minus pi over 4. It's just 8 pi over 4 minus pi over 4. This is just equals to 7 pi over 4. So this is just equals to negative 7 pi over 4. Okay. And we know that sine pi over 4 is just equals to sine negative 7 pi over 4. Cos pi over 4 is just equals to negative cos negative 7 pi over 4, and tan pi over 4 is just tan negative 7 pi over 4. Okay, if you press your calculator, you should get 0.707 if you check for both value. And if you find for cos pi over 4, you should get 0.707, and tan is just equals to 1. Okay. Right, now let's have a look at the last example. 610. 610. Okay, the first round is 360 degrees. Let me do it again. This is 360 degrees. Okay. This is 450 degrees. Plus 90, 540 degrees. 630 degrees. So 610 shouldn't go that way. It should go slightly left, something like that. Okay. Alright, let me repeat again. Okay, when we talk about 610 degrees, okay, this is 610 degrees. How does it go? 360, 450, 540, 610. Okay, so this is 610 degrees. You cannot go up until here. If you go up until here, it should be 630 degrees. But we just want 610. So we stop there. Okay. The corresponding negative angle. Okay. So basically, if you look at 610 degrees, I would say the corresponding negative angle is, if you look at from here until here only, it is 250 degrees. Okay, so it means that the corresponding negative angle is 110 degrees. Okay, so sine 610 degrees, basically we can say this is just equals to sine 250 degrees, which is just equals to sine negative 110 degrees. Okay, cos 610 degrees is just equals to cos 250 degrees, which is just equals to cos negative 110 degrees. And tan 610 degrees is just equals to tan 250 degrees, which is just equals to tan negative 110 degrees. Okay, let's check by using our calculator. Sine 610 is negative 0.9397. Okay, sine 250, the same, negative 0.9397, sine negative 110 is also the same, negative 0.9397. So as a conclusion, we can say that if we have an angle here, okay, if we have an angle here, okay, an angle here, okay, I name it as theta. So sine theta or cos theta or tan theta, sine theta, cos theta, tan theta is just equals to sine, name it as lambda, sine lambda, cos lambda, tan lambda, such that lambda is a negative angle. Okay, and also if we have more than one round, for example, if you have an angle this is your theta, okay, so sine theta is, or cos theta or tan theta is just equals to sine lambda cos lambda tan lambda. For example, say theta is equals to 480 degrees, say. So if we draw, it'll be like 360, 450, 480, something like that, theta. And we can also find that one, lambda. Lambda is just equals to 120 degrees, okay, because 480, this one 480 minus 360, you should get 120. Okay, we can say that sine theta is equals to sine 480 480 degrees is just equals to sine 120 degrees, and so on. Okay, don't get confused. You can try and error and look for the pattern on this graph, on these angles, and eventually when you do lots of practices, you will notice the patterns. Okay. Negative angles. For example, sine negative theta is equals to negative sine theta, cos negative theta equals to cos theta, tan negative theta equals to negative tan theta. For example, if you have sine negative 30, this is just equals to negative sine 30. Cos negative 40 is just equals to cos 40. Tan negative 420 is just equals to negative tan 120. And this all comes from that fact. Do you really need to remember this? No. Okay. This is just some basic knowledge that you do not need to remember. But yeah, this is the pattern that we can see. The relationship between positive and negative angles. Okay. Need to remember this? No. Okay, the next one is this. I would say 1, 2, 3, 4, 5. Maybe this is the 6 trigonometric functions. Okay, so this is the trigonometric functions. So very important for you to remember this. Let's see. Say we have the basic right angle triangle. Okay. This is the basic right angle triangle. So I name this as A and B and C. Or maybe, yeah, can be A, B, C. And say this is your theta. That is your angle theta, right? And we know basic Pythagoras theorem. Okay. States that A squared is just equals to B squared plus C squared. Okay. And also, you have learned that so cha toa, sine equals to opposite over hypotenuse. This is your hypotenuse. So cha toa. So hypotenuse is the longest side of the right angle triangle. I would say that hypotenuse is opposite of 90 degrees. Okay, so basically hypotenuse is the longest side. Okay, very important. So cha toa. For example, if you want to have sine theta, this is just equals to opposite over hypotenuse. In this case, opposite of theta is just B over hypotenuse A. Okay. So this is just B over A. Cos theta, cos is equal to adjacent over hypotenuse. Adjacent in this case is C, hypotenuse is A. So cos theta is just C over A. Tan theta is equals to, tan is equals to opposite over adjacent. Opposite over adjacent. So B over C. If I have another angle here, I name it as lambda. Okay. sine lambda is just equals to opposite. Sine is opposite over hypotenuse. Opposite is C, hypotenuse is A. So cos lambda equals to adjacent over hypotenuse. So B over A. Tan lambda is just equals to opposite over adjacent. Okay, so C over B. So this is the basic, and then we have a few new things, which is tan theta. Okay, tan theta is just sine theta over cos theta. Okay, sine theta we know that B over A. Okay. Let me do it like this. Okay. Maybe I use the green color. Right. Tan theta. Okay. Tan theta is equals to sine theta divided by cos theta. Okay. We want to prove this. This is true. Which is just equals to, what is sine theta? B over A divided by cos theta is C over A. And we know that when we have division, means that B over A, we can flip. So A over C, cancel out, we will eventually get B over C. So we can say that tan theta is obviously equals to B over C, which is just equals to sine theta over cos theta. So this one you need to remember. Okay. So this fact, first fact, you need to remember. Okay. When we have tan theta, the value is just equals to sine theta over cos theta. And then we have the other three things. Cot theta. So cot theta is just equals to what? Sec theta is just equals to what? Cosec theta is just equals to what? Okay, if we look at the third letter, this is T, this is C, and this is S. We can use this to remember the fact that cot theta is just equals to 1 over tan theta. Okay. Sec theta is just 1 over C cos theta, and cosec theta is 1 over sin theta. Okay, again, I repeat. The way we remember this, look at the third letter, T. So therefore, cot theta is just equals to 1 over tan theta. Sec theta is just equals to, because the third letter is C, So 1 over cos theta. Cosec theta, because the third letter is S, this is just equals to 1 over sin theta. And also 1 over tan theta is just equals to cos theta over sin theta. Okay. As a conclusion, apart from understanding the concept of Pythagoras theorem and also the fact of the basic Sochatua, here the basic Sochatua, you will also need to remember this formula here, because this formula will not be given in exam, so you need to remember. Let us repeat again for the last time. Okay. Sin theta is just equals to opposite over hypotenuse. Cos theta equals to adjacent over hypotenuse. Tan theta is opposite over adjacent, and also tan theta is equals to sin theta over cos theta. Cot theta, the letter is t, therefore this is just equals to 1 over tan theta. Sec theta, the letter is c, so 1 over cos theta. And cot theta, the letter is t. Cosec theta, the letter is s, so 1 over sin theta. And for cot theta, this is also equals to cos theta over sin theta. So basically, these are the things that you need to remember in order for you to answer the questions. Okay, basically we have done from the notes, we have done number 1, number 2, number 3, number 4, and number 5. Now we are going to have a look at number 6. Okay, now let's have a look at number 6. Suppose that I have this circle with radius r, and we have points here. 1, 2, 3, 4. Suppose that the coordinate of the first point A and B, which means that this is A and the height is B. Okay. And it is obvious that if this is A, here would be negative A, because we have that as origin, this point here, so that will be in a negative A, and the height is still B. Okay, and down here we have negative A, negative B, and the last one A, negative B. You need to remember, use Sochatua. So for theta, this is your theta angle. This is angle theta. Sin theta is opposite, which is just A, over hypotenuse R. So A over R. Cos theta is adjacent over hypotenuse. So adjacent is again, sin theta is opposite, which is P, over hypotenuse, which is R. Okay. So sin theta is just B over R. Cos theta is adjacent over hypotenuse, which is A over R. Tan theta is opposite over adjacent. That is B over A. Okay. Let's have a look at alpha. So which one is alpha? This one. This angle here. Okay. That angle there. Sin alpha is opposite, which is just B over hypotenuse, which is just R. Cos alpha is adjacent, which is just negative A over hypotenuse R. We can write as negative A over R. And tan alpha is opposite, which is just B over adjacent. This is negative A or negative B over A. Now let's have a look at beta. Sin beta is opposite over hypotenuse. So opposite going down is negative B over R. Okay. Cos beta is negative A over R, because this is negative A over R. And tan beta is just equals to opposite over adjacent. So opposite is negative B, adjacent is negative A. Negative B over negative A, negative divided by negative, we should get positive B over A. Okay, for the last one, alpha. Sin alpha is opposite over hypotenuse. So the opposite is negative B over R. Cos alpha is adjacent over hypotenuse. So this is just negative, adjacent is positive, so A over R. Tan alpha is opposite over adjacent, so negative B over A, because the adjacent is positive, opposite is negative. So this is just equals to negative B over A. Right. So for the next video, we will talk about properties number 7, which is so we've done with 5 and 6. So we are going to have a look at 7, which is the basic angle or the complementary acute angle.